Okay, in this video, we're going to look at how to determine the domain of a function. In my previous videos, we said if a function is defined by a relation, then the domain is the set of all the first components. So in this example, the domain of this function is this 1, 4, 7, and 9. Okay. Now next, we're gonna look at what if a function is defined by an equation. For example, here we have this function f(x), and the function f(x) is defined by this equation y equals 2 over x. Now let's think about, in this case, what is the domain of this function. Now we said when we define a function using an equation, this is like we have this machine, and all the x values are our input, and all the y values are our output. So in this case, to define the domain, it's like we need to determine what are our input, right? So this is like you have a microwave, right? And you want to think about, okay, what kind of thing I can put in the microwave. So, and the way we decide this is if the output is some weird number, well, the weird number, I will explain what does that mean. Then we cannot use the x as the input. So let's look at in which case, given this equation, in which case we will generate a weird number. So for example, if x equals 1, what kind of number I will generate? So if x equals 1, okay, this equation will generate 2. Okay, it's not a weird number. Right? Let's say if x equals pi. If x equals pi, the output is 2 over pi. Well, 2 over pi, it looks weird, but actually it's not weird because this number exists, right? And then what is a real number? What is a weird number? Let's think about what happens if our input is 0. Now, if our input is 0, according to this equation, our output is going to be 2 over 0. Now, what is a 2 over 0? Now, 2 over 0, you cannot find this number on the number 9, right? You don't know where to find this number 2 over 0. So here, if I have something like this, this is what I call the weird number. Okay? So the idea is, if the function is defined by an equation, and in this equation it contains denominator, then any number that make the denominator be 0, we cannot include them in our domain, because in that case we're gonna generate this weird thing, which is some number over 0. So using this method, let's take a look at another example. Okay, so now the function is defined by this equation y equals x plus 1 over x minus 1. And now we think about which number we cannot, or which numbers we cannot put in the domain. So to answer this question, we just look at which numbers will make the denominator of this expression be 0. Now the denominator of this expression is x minus 1. So which numbers will make x minus 1 be 0? Now this question is equivalent to what is the solution to this equation, right? What is the solution to this equation? Now, because 1 minus 1 equals 0, so the solution is 1. Therefore, 1, the number 1 will make x minus 1 be 0. So the number 1 will make the denominator be 0. So therefore, when we consider the domain of this function, fx equals x plus 1 over x minus 1. The domain is every real number except x equals 1. Because at x equals 1, if we use 1 as input, we're gonna generate a weird thing. And another way to represent this, another way to write the domain is is a set. It's a set, and it's a set. So here x is shows you this is the set of x, and x can be anything except 1.